Hi there! This is your Chief Marine Mate Edu at your service.
Now, but before we start, thanks for watching. Kindly click the subscribe button, notification bell, and like it if it pleases you. Let's begin.
This is the third segment in the part series of Liquefied Petroleum Gas Carrier Ship Cargo Operations. Let's continue from part 2, LPG Cargo Operations. Basically, this cargo sequence of operation is similar to what was discussed in part 2, which is inerting or preparation of gassing up. The only difference is that the atmosphere or present condition of the cargo tanks and its associated equipments are now in an inerted atmosphere within the entire cargo system, from cargo tanks to compressor room, pipelines, valves, and all other equipments where cargo can passes through. So in this view, the principles are the same, except that this time, with gassing up, we will be replacing the inerted atmosphere to a gas up condition. First, I will show you a brief overview why it is needed and how important it can be. As shown in this rectangular shape representing the cargo tanks, initially it was filled with air. And as shown here, if we gas up immediately without being inerted, then it will lead us to a hazardous situation where we are mixing air and hydrocarbons. However, it cannot be possible at all to proceed with such because it is not allowed, and by the rule of thumb, common sense applies. And so, it was inerted so that gassing up operation may follow. As shown again in this animation, gassing up is necessary because prior to loading, the tanks has to be gassed up, not just because it's part of the requirements, but by logic and principles. These are the following reasons. Item number 1. Inert gas is not compatible with LPG cargos. And these are the following reasons. Now, looking at this typical inert gas specification, which the byproduct used in inerting from our previous video segment, as shown here, the inert gas typical specification, nitrogen content is about 84%, carbon dioxide is about 15%, oxygen has about 0.5% maximum, could be less in more sensitive cargos. Now, this is what you have in your present condition of your tanks and the whole system of your vessel. So, hence, we need to get rid of all of these things as shown in this following. With these inert gas substances, carbon dioxide and water, which it's not a perfect system, you always get a little bit of it. When you load the cargo, cryogenic cargo or the refrigerated cargo at atmospheric temperature, that means to say it's very cold at its boiling point, then it will form ice. That's basically solids. You don't want to have solids in your system. If you are loading ammonia, ammonia plus carbon dioxide forms carbomates. And the same thing, you don't want to have carbomates, because this would definitely contaminate your cargo. And also, ammonia has a great affinity with water, and you don't want this to happen because it will produce ammonia hydroxide. Hydrocarbons plus water also forms hydrates with white crystalline substances, and you don't want to be included this into your cargo. If you are loading butadiene, if this is mixed up with oxygen, even if it's very minimal, it will become polymer and rubber-like. And also, it may become explosive. On the other hand, it will destroy the butadiene inhibitor if water is present. And thereby, it further produces polymers and rubbers without the inhibitor. So, solids and polymers are a no-no in your system. And of course, the most important thing is incondensable or non-condensable gases. You don't want this in your system when doing the loading, which will be explained in the next item. The last is dissolved gases in compressor lube oil, and the same principle, your compressor lube oil, if this is a non-oil-free type of compressor, most old type of designs of LPG ships, then these gases may dissolve into these compressors, and hence it will be absorbed by the lube oil, and this might contaminate your cargo if you are changing cargo, for example, and you will load that cargo and it passes through your compressor, then your cargo may go out of specification, and hence it will be contaminated. So that is the number one reason for gassing up. Number 2, gassing up will also meet the criteria based on eliminating the side of a fire triangle, which was discussed earlier. At this point, it's not only the oxygen was removed, but in all actuality, by looking at these lower and upper flammable limits, you can find here the graphs, the tanks or associated system are rich with hydrocarbons. And so, if we have a rich hydrocarbons in your system, in this view, by looking at the graph, the volume of hydrocarbons is so rich, so even with almost 0.5 or even less percentage by volume ratio with oxygen, this means it cannot support fire or explosion even with the presence of heat or ignition sources. So that's the reason for item number 2. And lastly, for item number 3, this is not necessarily in order. When cooling down or loading commences, the liquefaction function plants can be commissioned easier with less delays. As mentioned in item 1, we have a lot of incondensable gases. Now this could be confusing to most. Nitrogen and air are basically termed as incondensable or non-condensable. Non-condensables are gases that will not condense into a liquid, take note, within the operating temperatures of the refrigeration system. Hence, the liquefaction function system of the ship was not designed to condense nitrogen, oxygen, or carbon dioxide and other gases produced by the inert gas system, which has replaced the air in your cargo tanks during inerting. Thus, gassing up is necessary other than the reason laid out in item 1 and 2. This is a sequential SOP or standard operating procedure in order for the liquefaction function plants optimize its performance and work at maximum. To sum it up, getting rid of these unwanted gases such as nitrogen would speed up the process of commissioning your liquefaction function plant during cooling down and loading operations. Let me give you another example. If methane vapor or natural gas is present in the tank, the methane gas as well will be termed non-condensable. Because it's obvious, cargo liquefaction function plants in this vessel are not designed for it. But in liquefied natural gas or LNG ship fitted with a liquefaction function system, then such natural gas can be condensed back to liquid using liquid nitrogen. So, with this explanation, which has been expounded, we are now able to understand the need for gassing up. As such, let me demonstrate gassing up. First, we go back to the comparison of density of gases chart. As shown here, inert gas is lighter than gassing up medium, which is, for convenience, we shall use the cargo propane as the cargo to load. Hence, the vapor density of propane is heavier than inert gas present in your cargo tanks and associated equipment. Using the rule of the thumb, since displacement is mostly widely used, then the heavier medium should be in the bottom. Hence, propane vapor will be introduced through the bottom via the draft line or loading lines or parts line, and in turn, the inerted atmosphere of your tanks will be displaced, pushed up and out through the top parts line or vapor line. Now, there are other alternatives of doing this depending on the design and layout of your cargo fittings, pipelines, and equipments. So, the question arises, where do we get the gassing up medium or propane vapor? There are two possible ways. For the sake of argument, this can be supplied as a gas from the terminal via your manifold lines. However, not very common, not practiced, and in most cases very unlikely. Hence, the standard practice is to load a certain amount of liquid cargo will be loaded to one of your tanks or deck storage tank if fitted, or slowly receiving such liquid and directly sending it via your cargo vaporizers. There is a formula to find the optimum amount to load just enough to complete gassing up, or the chief officer usually base it on the gas form C or previous operations they had with similar cargoes. And so such quantity can be ordered from the terminal or from the other ship if such operation is taking place in STS, ship to ship. If there is an excess of this liquid used for gassing up, it may be used initially as well or even completely do the cooling down operation, which will be discussed in part 4 segment discussion. Once the gassing liquid is on board, the gassing up commences. Of course, prior to this undertaking, such operation has been planned, laid out in details, and prepared like lining up pipes, valves, spool pieces, amongst many other things, with your gas engineer and the rest of the deck crew through the master supervision, approval, and in coordination with the operation department, the terminal site, or the other ship if in STS operation. Okay, Before we start with the gassing up demonstration, let's have some gassing up reminders. The discharge temperature from the vaporizer is important. The ideal is to maintain the temperature at about the same as the cargo tank temperatures on commencement of the operation. For this reason, this will ensure that the minimum amount of liquid and hence time is used to undertake the operations. Warmer temperature vapor will occupy greater volume without warming the tanks any further. However, the discharging temperature must be above the dew point temperature of the inert gas within the cargo tanks. And so, let's now proceed to the demonstration of gassing up methods and introduction. It is possible to gas up the cargo tanks using the series or cascade method of purging. This is where the vapor is introduced into the bottom, taken from the top of the first tank and fed into the bottom of the next, and so on and so forth, rather than venting it directly to the atmosphere. This method minimizes the amount of cargo loss and also ensures that all but the last tank are fully gassed up, which ensures easier starting of the reliquefaction plants. Now let's demonstrate using a simulator. Using the simulator displayed here, we will be taking in the liquid cargo and then we will load it to the deck, so storage tank of your LPG, if fitted. So in this scenario, we will take off the blinds first, and then of course we will connect the manifold and we'll get a supply from the shore side or terminal. So of course we will open some bulbs, and as you can see, if we trace the line, we will be using number 1 and 4 liquid line and passes through a strainer, and this is number 1 and 4 liquid line. So now if we go to the cargo pipeline, so this is the main general layout of your cargo pipelines, and if we trace the lines, this is the 1 and 4 lines, so number 1 tank and number 4, and you trace the lines of blue lines. We need to connect these spool pieces, put in, and if we trace here, it goes through here, and then we need to open this one because we will be loading through the deck storage tanks. So we will be using that condensate line, and it passes through here, and then we need to connect the spool pieces there also. Of course, this has been done on hand or beforehand. And now up to the port side deck pressure vessel. So now we need to do is line up and open the valves as remaining valve, ready to receive the liquid cargo for gassing up. So okay, from the manifold it passes to number 1 and 4 system. It cannot go through this area because there's no spool piece. We have this spool piece here, it goes through here, and then we open this bulb is closed, it goes to the yellow or condensate line and down here, and then through this spool piece, and again another spool piece just before the deck storage tank on the port side, and we open the bulb, and through the bottom we load the estimated amount of liquid to be used for gassing up. So after taking in the liquid for gassing up, we close now deck storage tank for the meantime. And then when we are ready, we reline up for gassing up by diverting the liquid from the deck storage tank to the vaporizer. So if we trace the lines again, we go here. This one is still open. And since we close the bulb from the deck storage tank, and this is spool piece is still connected, and it passes through here. Then hence from this area, it passes then again here. And then we send it through the vaporizer. Now this type of LPG design, the vaporizer is fitted in the compressor room. It's a combination condenser and vaporizer. So as we trace the line, it goes through here, and we will be using the plant number 1. So this is plant number 1, and as mentioned earlier, it's a combination of vaporizer into the cargo condenser. So hence from that liquid line, we should open this one based on the main overview of the pipelines, and I'll show you later. And of course we will be opening this inlet and outlet of the steam. So hence the liquid will be filled into the cargo condenser. A little bit of this amount will be monitored so that we would know. At the same time, we open where this B95 or bulb 95, where the vapor will come out. So again, liquid turns to vapor because we have the steam going through the vaporizer. It vaporizes the liquid and comes out top of that vaporizer. So looking at again at cargo main overview. We could see here that the plant number 1 in the combination of the condenser vaporizer, we have open valve C58 and then it comes out from valve B95. But of course, before starting the steam and vaporizing the liquid, we should have lined up as well beforehand the series or cascade type of introducing the vapor to the tanks. And again, as mentioned earlier, it will pass through the bottom, comes out from the top and goes to the other tank in the same way as it finishes till the last tank. So again, if we open this valve right now, through pressure it pushes the liquid, goes through this line, through the condensate line with these spool pieces and goes down and inside to the compressor room where your vaporizer is located. And then of course, if you open the steam, it vaporizes, it goes out again through the valve 95. So okay, as we trace the line, we will be using a series or cascade type of displacement for gassing up. So through here, we send vaporized gas through the number 1 and 4 system, going to the drop line of tank number 1, and then out to the vapor line, and goes out. And as you can see, these lines are not interconnected because they are just pipelines passing on top or beneath each other. So again, there is a spool piece here, up through here. It's not going anywhere but to tank number 4. But we cannot utilize the vapor of tank number 4 because it will be interconnected with number 1. So instead, we diverted it to the number 2 and 3 cargo tank system using the liquid line. Of course, it's vapor that's passing through. Putting up spool pieces. This one is closed, the valve here, and spool pieces here is not connected, so it's not going anywhere. But it goes through here and connected to number 1 and 4 system. So again, it goes down all the way to number 4 cargo tanks, down to the bottom, and then comes out of top purge. Instead of the vapor line, as I mentioned earlier, it's interconnected already to number 1. So we will be using top purge to take out the vapor, so push out the inner gas, and it goes out from here, and then interconnects to number 3 cargo tanks, all the way down to the bottom. So from there, it's not interconnected with any spool piece with any other system other than number 3. It goes down to the bottom and then comes out from the vapor line of cargo tank number 3. And there we have spool pieces connecting to system number 2 cargo tanks. And from cargo tanks number 2, as you can see the line, it's not going anywhere, but we have to utilize another pipeline that comes down here. And as you can see, it goes up and join the number 2 system. So again, spool pieces are not connected here, so it's not going anywhere. And so with this one, and this one is not interconnected at all because they are separate lines. And so with this one, and then the valves open here, and all the way to the bottom of the last tank, which is number 2. And then of course, it comes out of top purge from number 2. We cannot open vapor line because again, it interconnects with cargo tank number 3. So from top purge, it will go now to your mass riser. Now, as shown earlier, the vent mass riser was utilized to vent out the gases. So in this scenario, we will be using the manifold because I have demonstrated as if we are at open sea or doing STS or ship to ship. So in this case, the vessel is alongside and port side alongside actually. So in this case, we will be utilizing another configuration. This depends of course on the system that you have on board, like I have mentioned a couple of times. So there are many ways that you can do so. We can even use flexible hoses if we have flexible hoses, so that if there is no way for you to interconnect pipelines, then flexible hoses are very useful. In this scenario, utilize this valve 124 goes all the way down to cargo tank number 2. And as you can see, it goes to the drop line again, to the bottom, and comes out of the top purge. From the top purge, it goes to this line. And as you can see, this valve is closed. It's not going anywhere but here, and all through this line and to this system 1 and 4. So this spool piece is not connected here so that it cannot go to the other system. So basically goes specifically to number 4 cargo tanks. And likewise, goes to the bottom and then comes out of top vapor line. From vapor line of number 4 tank, it goes through here. We cannot utilize again this line because it interconnects with number 4 vapor line. So we cannot use that one. Instead, we diverted it through here by spool piece and interconnects it to number 2 and 3 system. So in this way, we will be able to send the gassing up vapor all the way to cargo tank number 3 bottom. And again, comes out of vapor line of number 3. Again, we cannot interconnect the vapor line of number 2 and 3 because we need to push this vapor or gassing up medium all the way to cargo tank number 1 because this is your last tank. Again, as you can see, the spool pieces are connected and it's not going anywhere. There is no backflow because the valves are closed for number 4. So it goes only in one direction all the way to tank number 3, which is your last tank. All the way down to the bottom and comes out to the top of the vapor line and all the way to your manifold through these spool pieces and to the number 1-4 system. So if I show the manifold right now and it comes out from number 1 and 4 system and through here and there you go, you are connected to the shore terminal, the valves are open, the checksum or manifold are connected and it bed out to the riser of the terminal. Now, one way of other measuring or monitoring the completion of gassing up is that observing vent mass riser of the terminal, it comes out with a black smoke. Later on, when the gassing up is completed, of course it takes time, this will become clear and in most cases there is fire in that smokestack. So there you go. Of course, this is gradually to be monitored in an hourly basis or even shorter basis. You'll be able to see also the average changes of the atmosphere and you'll be able to see the rate of changes. So you'll be able to come out with estimation of completion. In fact, if you check with your guidelines and your gas form C, you'll be able to see there already the estimated time of completion. But again, of course, sometimes you are affected by other conditions like the weather and of course your system, some limitations, and so many factors involved. So monitoring is the best way, and of course gas measuring equipment like the hydrocarbons, sampling system. Once you have done with the tanks, then you can go with the rest of your lines and system like with the inerting procedures that we have done in the previous discussion. Meaning to say, you go over with all the valves, lines, equipments, and your compressed rooms and systems until you complete all the gassing up of all your LPG system related cargo operations. Part 3 series gassing up operation has been completed. To resume with the next series of part 4, keep posted. We will be discussing reliquefaction plant in the next episode.